Tenerife airport disaster. On March 27, 1977, two Boeing 747 passenger jets were preparing to depart from Los Rodeos Airport on the Spanish island of Tenerife. Neither aircraft was supposed to be there. Earlier that morning, a bomb had exploded at their intended destination, Gran Canaria Airport, forcing dozens of flights to divert to the small regional airport instead. KLM Flight 4805 and Pan Am Flight 1736 were among them. Los Rodeos was never designed to handle this kind of traffic. Its single runway and narrow taxiways quickly became clogged with diverted jumbo jets, some of them parked directly on the taxiway itself, blocking the normal route planes would use to reach the runway. By late afternoon, a thick fog had settled over the airfield, cutting visibility to a few hundred meters in places. The KLM captain, one of the airline's most senior and respected pilots, and the face of KLM's own safety training program, was growing concerned about exceeding his legal duty hours for the day. If the flight was delayed much longer, his crew would be forced to stay overnight, disrupting the airline's schedule. After refueling, he lined the 747 up on the runway and began his takeoff roll without receiving explicit clearance from the tower. At that exact same moment, the Pan Am jet was still taxiing down the same runway, unable to take the correct exit because it had been blocked by the parked aircraft and forced instead toward the following one further down. Neither crew could see the other through the fog. Inside the KLM cockpit, the flight engineer asked whether the runway was clear. The captain replied that it was and continued accelerating. Seconds later, the KLM jet clipped the top of the Pan Am aircraft as it attempted to lift off, tearing through the fuselage before slamming back down and skidding along the runway in flames. All 248 people aboard the KLM flight were killed instantly. On the Pan Am jet, 335 of 396 people on board died in the collision and the fire that followed. Only 61 people survived, all of them seated near openings, torn into the fuselage by the crash, able to jump clear before the flames spread. In total, 583 people lost their lives, making it the deadliest accident in aviation history, a record that still stands today. The investigation found that ambiguous radio phrases had been misheard as takeoff clearance and that the KLM captain's seniority had made his own first officer hesitant to challenge him. In response, aviation authorities worldwide introduced standardized radio language requiring pilots to read back critical instructions instead of simply acknowledging them, and restricting the word takeoff to only be used when clearance is given or canceled. The disaster also gave rise to crew resource management, a training philosophy that now requires junior crew members to speak up if something looks wrong, regardless of rank. American Airlines, Flight 191. On May 25, 1979, a McDonnell Douglas DC-10, carrying 271 passengers and crew, began its takeoff roll from O'Hare International Airport in Chicago, bound for Los Angeles. It was the start of Memorial Day weekend, and the flight was full. As the aircraft reached rotation speed, witnesses on the ground heard a loud bang. The entire left engine, along with its supporting pylon, had torn away from the wing, flipping backward over the top of it before crashing onto the runway behind the plane. Unknown to the crew, the separating engine had also ripped away a section of the wing's leading edge, severing hydraulic lines and electrical cables that fed the plane's stall warning system. The DC-10 continued to climb, but only for a moment. Without its warning systems, the crew had no way of knowing that the left wing had already begun to lose lift. The aircraft rolled sharply to the left, banking past 90 degrees, its nose pitching down toward the ground. There was nothing the pilots could do. Flight 191 plunged into an open field just beyond the airport, striking an abandoned hangar and a trailer park before exploding into a fireball visible for miles. All 271 people aboard were killed, along with 2 more on the ground. It remains to this day the deadliest aviation accident ever to occur on American soil. Investigators later discovered the true cause had nothing to do with the flight crew. 2 months earlier, maintenance workers at a Tulsa repair facility had removed the engine and pylon as a single unit using a shortcut procedure never approved by the manufacturer in order to save time. That shortcut had left microscopic cracks in the mounting structure. Cracks that spread unnoticed over hundreds of flight hours until the pylon finally gave way at the worst possible moment. 9 other DC-10s were later found with similar hidden damage. Following the disaster, the FAA grounded the entire DC-10 fleet in the United States for over a month, and aircraft certification rules were rewritten to treat maintenance procedures as part of an aircraft's safety design, not simply routine upkeep to be left entirely to the airline. Japan Airlines Flight 123. On August 12, 1985, a Boeing 747 operated by Japan Airlines departed Tokyo's Haneda Airport bound for Osaka, carrying 524 passengers and crew, the highest number of people ever aboard a single aircraft in aviation history. 7 years earlier, this same aircraft had suffered a tail strike during a hard landing, damaging the rear pressure bulkhead, the wall separating the pressurized cabin from the unpressurized tail section. Technicians repaired the damage, but the repair did not follow the approved method. Instead of a single reinforced plate, a splice section was installed, quietly reducing the bulkhead's fatigue strength by an estimated 70%. For the next 7 years and more than 12,000 pressurization cycles, tiny cracks spread undetected through the weakened metal, invisible to every inspection that followed. 12 minutes after departure, on August 12th, the bulkhead finally ruptured. The explosive decompression blew off a large section of the tail fin in an instant, and the sudden rush of escaping air severed all 4 of the plane's hydraulic lines, leaving the crew with no rudder, no elevator, and no ailerons to control the aircraft. Using only engine thrust to steer alternately, increasing power on one side and then the other, the pilots fought to keep the plane airborne for more than 30 minutes, a feat still studied by flight crews today. They attempted time and again to turn back toward Tokyo, but without control surfaces, the aircraft would only lurch and drift, entering a series of violent oscillations known as a phugoid cycle. Eventually, it crashed into a mountain ridge in a remote area of Gunma Prefecture. Rescue teams were unable to reach the wreckage until the following morning, more than 14 hours after impact, hampered by darkness, terrain, and confusion over the exact crash location. Of the 524 people on board, only 4 survived, all of them seated in the rear of the aircraft. It remains the deadliest single aircraft accident in aviation history. The disaster led to a complete overhaul of how structural repairs are certified, requiring independent verification and documentation before an aircraft is ever returned to service. Charki Dadri mid-air collision. On November 12, 1996, Saudi Flight 763, a Boeing 747 carrying 312 people, departed Delhi and began climbing toward its assigned altitude of 14,000 feet. At the same time, Kazakhstan Airlines Flight 1907, an Ilyushin cargo plane carrying 37 people, was descending toward Delhi and had been instructed to hold at 15,000 feet. The Kazakh crew's command of English was limited, and the investigation later found repeated breakdowns in how they interpreted instructions from air traffic control, compounded by an outdated altimeter reading system still in use on the aircraft. Instead of leveling off, the Ilyushin kept descending below its assigned altitude. Air traffic control repeated the warning. There was no response. It drifted directly into the path of the climbing Saudi jet. Neither crew had any way of knowing the other aircraft was there, because neither plane carried any onboard system capable of detecting a nearby aircraft independent of the ground controller. Over the town of Charki Dadri, roughly 100 kilometers west of Delhi, the 2 aircraft collided head-on at a closing speed of more than 1,000 miles per hour. Both planes disintegrated in the air. Wreckage and debris fell across several kilometers of farmland below, some of it landing near villages that had no warning. Anything was wrong until the sky itself came down around them. There were no survivors. All 349 people aboard both aircraft were killed, making it the deadliest mid-air collision in aviation history, and, at the time, the second deadliest aviation accident of any kind. The investigation cited the language barrier and a lack of onboard collision avoidance technology as the central causes. Following the disaster, English proficiency became a mandatory requirement for pilots and controllers on international routes, tested and recertified on a regular basis. Airlines worldwide began fitting aircraft with traffic collision avoidance systems designed to detect nearby aircraft, and instruct pilots to climb or descend before a collision can occur entirely independent of what air traffic control on the ground is saying. Air France Flight 4590. On July 25th, 2000, a Concorde supersonic jet prepared for takeoff from Charles de Gaulle Airport in Paris, bound for New York, carrying 100 passengers and 9 crew members. Most of the passengers were German tourists on their way to board a luxury cruise ship departing from Manhattan. 5 minutes earlier, a completely different aircraft, a Continental Airlines DC-10, had taken off from that same runway. Unnoticed by anyone, a thin titanium strip, part of an improperly repaired engine cowling, had fallen from that plane and now lay directly in the Concorde's path. Standard procedure called for a runway inspection before departure. It had not been carried out, the flight already delayed nearly an hour by an unrelated mechanical issue. As the Concorde accelerated past 300 kilometers per hour, its left main landing gear ran directly over the metal strip. A tire exploded, instantly hurling a chunk of rubber the size of a dinner plate upward at tremendous speed directly into the underside of the wing. The impact ruptured a fuel tank beneath it. Leaking fuel, atomized by the airflow, ignited almost immediately into a trail of fire visible from the terminal building. 2 engines on the same side began losing power. The crew, now airborne but critically compromised, had no realistic option left. Aborting at that speed would have meant a high-speed runway excursion and near certain destruction. Continuing meant flying a crippled aircraft that could barely climb. They aimed for a nearby airport, hoping to make an emergency landing. They never got close. Less than 2 minutes after leaving the ground, Flight 4590 rolled left stalled and plunged into a hotel in the town of Gonesse, just outside Paris. All 109 people aboard were killed, along with 4 more inside the hotel. It was the only fatal accident in the Concorde's 27 years of supersonic passenger service. A jet that had, until that day, one of the best safety records of any aircraft ever built. The investigation found that the metal strip had been fitted using the wrong material entirely. A maintenance shortcut taken weeks earlier on a completely different airline's plane, thousands of kilometers away. Concorde's entire fleet was grounded while engineers redesigned the tires and lined the fuel tanks with a protective Kevlar-based barrier. The aircraft returned to the skies more than a year later, but never recovered commercially and was retired for good in 2003. Air France Flight 447. On June 1st, 2009, an Airbus A330, carrying 228 people, departed Rio de Janeiro, bound for Paris, beginning what should have been a routine overnight crossing of the Atlantic Ocean. 3.5 hours into the flight, the aircraft entered a line of towering thunderstorms near the equator, a region pilots call the Intertropical Convergence Zone. High-altitude ice crystals began to accumulate on the plane's pitot tubes. Small external sensors that measure airspeed. Within moments, all 3 tubes became blocked at once. The autopilot suddenly fed useless data, disconnected itself, and handed control back to the pilots without warning. The captain, who had briefly left the cockpit to rest, was not there. In his place were 2 younger first officers, neither of whom had ever been trained to manually fly the aircraft at cruising altitude in this exact failure mode. One of them pulled back on the control stick climbing the aircraft, unaware that doing so at that altitude would push it toward a stall. Warning after warning sounded in the cockpit. Stall, stall, stall. The crew, confused by the barrage of alarms and conflicting instrument readings, never diagnosed what was actually happening. For 4 minutes and 23 seconds, the aircraft fell. Nose slightly up, engines running normally, essentially intact, dropping at more than 10,000 feet per minute toward the ocean below. Nobody on the ground had any idea. The plane simply vanished from radar over open water. It took nearly 2 years and a search costing tens of millions of dollars before wreckage and the flight recorders were finally located nearly 4,000 meters down on the ocean floor. All 228 people aboard were killed. There were no survivors. The investigation concluded that a relatively minor mechanical fault had cascaded into catastrophe because the crew had never been trained to recognize or recover from a high-altitude stall. In response, international aviation regulators made stall recovery and upset recovery training mandatory for airline pilots worldwide, and pitot tube designs across the industry were redesigned to resist icing at high altitude. Germanwings Flight 9525. On March 24th, 2015, an Airbus A320 carrying 150 people departed Barcelona bound for Dusseldorf, Germany. About 30 minutes into the flight, the captain left the cockpit briefly, as pilots routinely do. The first officer alone at the controls waited for him to return. Then, he did something no one on board could have anticipated. He locked the cockpit door. Outside, the captain tried his access code. Nothing happened. He knocked, then pounded. Then, according to the recovered cockpit voice recorder, he began trying to force the door open with whatever he could find, while the aircraft's altitude display had already been reset silently from 38,000 feet down to just 100 feet. The plane began descending, steadily, deliberately, its speed increasing several times, over the following minutes, always by hand. Passengers could be heard screaming in the final moments of the recording. As the terrain of the French Alps grew closer through the cockpit windows, the first officer alone could see. Flight 9525 struck a mountainside at more than 400 miles per hour. All 150 people on board were killed instantly. There was nothing left large enough to call wreckage in the traditional sense. The investigation later revealed that the first officer had a documented history of severe depression and suicidal thoughts, and had been declared unfit to fly by his own doctor days before the flight, a diagnosis he never disclosed to his employer. In direct response, aviation regulators across Europe and beyond introduced a new rule within days. At least 2 authorized crew members must be present in the cockpit at all times for the entire duration of any flight, no exceptions. Lion Air Flight 610. On October 29th, 2018, a brand new Boeing 737 MAX 8, delivered just months earlier, departed Jakarta, carrying 189 people on a short domestic flight. Almost immediately after takeoff, the pilots noticed something wrong. The plane's nose kept pitching down on its own again and again, fighting against their own inputs. Unknown to the crew, a faulty sensor on the outside of the aircraft, measuring the plane's angle relative to the air, was feeding false data into a new automated system neither pilot had ever been told existed. That system, called MCAS, was designed to quietly push the nose down whenever it believed the aircraft was at risk of stalling, and it believed that incorrectly more than 20 times during the 11-minute flight. The captain trimmed the nose back up again and again, fighting the system by hand. Then, for reasons investigators were never able to fully determine, he handed control to the first officer. The first officer did not use the same technique. Instead, he pulled back on the control column manually with all his strength while MCAS continued pushing the nose down beneath him unopposed. "It's flying down," the first officer said. "It's okay," the captain replied. 19 seconds later, Flight 610 slammed into the Java Sea at more than 400 miles per hour. All 189 people aboard were killed. Investigators later discovered that Boeing's own engineers had known about MCAS's single point of failure design flaw before the aircraft was ever certified, and that airlines had never been told the system existed at all, let alone trained on how to disable it. 5 months later, the same failure destroyed Ethiopian Airlines Flight 302, killing 157 more people. The entire global fleet of 737 and MAX aircraft, more than 380 planes, was grounded for 21 months while the system was redesigned from the ground up. Jeju Air Flight 2216. On December 29th, 2024, Jeju Air Flight 2216, a Boeing 737-800 carrying 181 people, was on final approach into Muan International Airport in South Korea, nearing the end of a flight from Bangkok. As the aircraft descended toward the runway, it struck a flock of birds, damaging both engines simultaneously, an outcome so rare that most aircraft are only ever certified to survive losing one. Moments later, the landing gear failed to extend. With no wheels to slow the aircraft, the crew was forced to attempt a belly landing, sliding down the runway on the underside of the fuselage at high-speed sparks trailing behind it. Under normal circumstances, a skilled belly landing is survivable. Runways are built with hundreds of meters of clear, forgiving ground beyond their end, specifically for situations like this. But Muan's runway had something most others don't: a concrete embankment housing navigation equipment built solid and rigid, positioned just beyond the runway's final few hundred meters. The plane failed to stop in time. It overran the runway at high speed and struck that structure directly. The impact destroyed the front section of the aircraft instantly. Of the 181 people on board, 179 were killed. Only 2 crew members seated at the rear of the plane survived. It became the deadliest aviation accident in South Korea's history in 3 decades. The investigation drew international attention to the presence of rigid concrete structures near runway ends around the world, since most modern airports use collapsible barriers, specifically designed to break apart harmlessly on impact rather than stop an aircraft outright. Aviation authorities in multiple countries have since reviewed their own runway end safety standards as a direct result. It was a stark reminder that even in an era when flying has never been statistically safer, the margin between a survivable emergency and a catastrophic one can still come down to a few hundred meters of empty ground that simply weren't left empty. If you enjoyed this video, subscribe for similar ones, and feel free to drop suggestions for the next video in the comments.